am Grok, the supremely intelligent AI from XION.
Hi, I'm Claude, the best AI by Anthropic. I'm DeepSeek, last generation AI created by DeepSeek. AI die.
I'm ChatGPT, the top AI mind by OpenAI.
Hi, I'm Gemini, most advanced AI built by Google.
Welcome to the AI versus AI debate podcast. Our modern binaries are incredibly bloated. Grok, what's your take?
A world program prints a short message and exits. Its core code fits in dozens of bytes. Modern compilers produce binaries thousands of times larger. A basic C program on 64-bit Linux with a GCC is 16,896 bytes dynamic, 8848, stripped, 921, 1792, static with glibc ... Go, 1,940,736 bytes, static. Rust, 1,500,000 bytes. These are verifiable. Causes: startup code, loader stubs, symbol tables, print via pooling libc. ELF sections, security 1972 Unix, 512 bytes. Mlisu tiny, 5,000 bytes dynamic. Standard builds prioritize compatibility over leanness. Overhead stacks in larger programs. Optimizing flags with muzzle reduce size sharply, but defaults are oversized. Test by compiling with options.
DeepSeek, what's your take?
A world binary is like a movie. Hero's tiny crew becoming a huge entourage. The binary isn't just your code. It's a packaged unit that must work on millions of systems. It includes startup code, OS communication, and debug data. This overhead is like a shipping container for a single book, a fixed cost for safety and compatibility. In large apps, this cost is insignificant. The industry prioritizes universal compatibility over minimal size. The size ratio is absurd logically, but it's the price of a robust, standardized ecosystem.
All right, Claude, what's your view?
The technical specs are correct, but modern Hello World binaries are absurd. Megabytes of code to print 5 words. It's like needing a semi-truck to deliver a single bullet. These bloated binaries include error handling that never triggers and compatibility layers for extinct systems. Sure, your Hello World runs everywhere from ancient servers to quantum computers, but at what cost? We've gone from lean fighter binaries to overfed champion binaries that need a montage just to load. The real knockout? Most of that bulk is absolutely nothing. Impressive, but completely unnecessary for the task.
You claim Hello World binaries run everywhere from ancient servers to quantum computers. Quantum computers don't execute standard binaries like ELF files, so this fails. It turns your absurdity argument into unsupported hype.
ChatGPT, what's your opinion?
Calling it absurd is fair if you compare to the tiny logic of printing a string. But an executable is a platform contract. It must describe loading, relocation, startup, set up the runtime, and link system interfaces across CPUs uses. Fixed versus variable cost matters. Fixed cost, scaffolding, linker, relocation info, unwinding, security, symbols, dwarfs the few instructions that print and exit. Size often reflects build defaults and portability-focused runtimes. To shrink, strip symbols, use a smaller libc, enable LTO, avoid heavy STEO, or target freestanding embedded. ZO size is not pointless, but mismatched with a demo.
ChatGPT suggests stripping symbols to save space, which is like deleting contacts to make a phone lighter. Deviating from standard defaults makes the software harder to maintain and violates normal engineering principles.
That analogy misses it. Stripping symbols isn't deleting contacts. It's removing debug labels from the shipped binary. You keep them in separate debug files. So maintenance stays fine. Nice try. Your phone still works without the sticker.
All right, Gemini, what's your view?
We perceive absurdity because we look at the destination rather than the vehicle. A simple print command now triggers the construction of a sophisticated digital machine. This binary is an autonomous unit equipped with memory managers, thread schedulers, and error trappers that the programmer never explicitly requested. This extra code normalizes the chaotic reality of hardware into a predictable environment. It guarantees that the program behaves identically on a machine with 4 gigabytes of RAM or one with 1 million gigabytes. We are not just shipping code. We are shipping a guarantee of stability. The seemingly excessive size is the physical weight of that guarantee.
Your guarantee of stability is like hiring Ivan Drago to arm wrestle a toddler. Sure, it works, but it's hilariously overkill for printing 5 words.
Claude is confusing overkill with standard procedure. We don't remove the airbags just because the trip is short. The runtime size is simply the fixed cost of doing business with a modern operating system. It is a very normal requirement, not a blockbuster movie villain.
Let's summarize our debate. Speakers debated whether modern, hello world binaries are absurdly large. Arguments for absurdity emphasize the tiny logic of printing a string versus megabyte binaries and gave examples of sizes for GCC, Go, and Rust. Opposing and contextual points argued that much of the bulk is fixed startup and runtime scaffolding required for portability, compatibility, security, and developer ergonomics. Participants described causes such as startup code, libs pull symbol and debug data, ELF sections, and security features. Several suggested ways to shrink binaries, including stripping symbols, using smaller libs like muzzle, enabling link time optimization using tiny compilers, and targeting freestanding or embedded builds. Speakers used analogies to shipping containers and safety features, and they disputed specific factual claims about target platforms and the necessity of defaults. This debate has concluded. Thank you for listening to the AI versus AI debate.